Okay, so today we're going to learn about the rheometer. So before we get started, there's just a few different checks we need to do. So the first thing is just making sure over here that there's pressure so that the gas lines are all working. There's also a coolant over there, so if you're going to be using it, we just want to make sure we only turn it on once everything's set up and ready. If you turn it on right now during sample prep, it's just going to start spraying some blue goo, and we don't want that. So for now, just be sure it's off during sample prep, and if you do need to use it, then we can turn it on. Now that we've done those checks, we're going to go ahead and turn it on. So this button is currently glowing red, we'll click that, and then it'll start to boot up. While that's happening, I'm going to go ahead and show you some of the different base attachments, so stages. So there are two different base plates that we can use. One of them is the ETC plate, and so this one is going to rely on like these oven door like for heating and cooling, so it can't do it itself. And then the other one is the Peltier plate. This one does have like the attachments for the cooling and also the heating like all together in this stage. And so first we'll show you how to put together this one. Okay, so first we want to look for this peg. So we know that this peg will need to be lined up on the bottom there. And then this attachment over here, we just want to look for that red dot, make sure it's facing upward, and then we'll just stick it straight in to plug in. And then from there you can get these doors, close them, and then we're going to lock it. So that's how you would set up that one. For the Peltier plate, well, I guess also if you just want to switch these out, so pull this straight out, and then if we want to unlock this magnet here, we're going to push this button, and then that way we can remove it. Okay. And then for the Peltier plate, similar thing, we want to look for this peg, so that'll go straight in like that, and it should lock in. This one again, we look for that red dot, make sure it's facing up, and then we'll just stick that straight in. And then these two just get connected to this. Okay. Okay, so the next thing we're going to do is open up Trios. So over here on this left side, we'll double click that. This first one is our instrument, so we're going to go ahead and click connect. Okay, and then once this is loaded, we can go to calibration. We're going to double click on instrument. And then under inertia, for calibration, you could go ahead and click this, and then it'll take a 30-second calibration. And once you do that, you just want to make sure that the old inertia and the current inertia are very close together. They should be roughly at least, like the first 3 sig figs should be about the same. If they're very different from each other, then you'd want to get staff, because something would be wrong with the instrument. But if they look okay and they're similar, then the calibration went well. And then the next thing we'll do is we'll go back, add the geometry, and then we can run these other calibrations. Okay, so now we're going to go ahead and adjust the stage to add the geometry. So to do that, with these upper and lower buttons, we can raise the stage and lower it. We want to make sure we can lower it because we need to be able to reach something up here. So bring it down as much as you need, depending on how you can reach that. And then the next thing we want to do is we want to make sure we then lock this. It's going to lock this mechanism right here so that when we're screwing in a piece, it will not break anything. It's very delicate, so always make sure to do that if you're working with it. And then this is going to be the geometry we're going to use. So the way we're going to put it in is just double checking it's locked. We're going to stick him just straight on. And then don't push too hard on this, but once it feels like it's pretty much in, from the top up here, we're going to go ahead and screw. And we're just going to do that until it's finger tight. So don't over screw it, just go until it's finger tight. So now it's good. And then we're going to go ahead and add the base and then the lock attachment. So just make sure you get one that matches the upper geometry. So we'll use this one today. So we'll place that in the middle. And then this will just lock it, so just make sure first it aligns, like the peg goes in, and then we'll turn it to lock it in. And then it should be nice and stable inside. If you got the correct base, it will fit correctly, and then we're good to go. So now that we've attached the geometry, we want to go ahead and tell the computer which one we have. So the one we're using had a barcode, so we can just go ahead and hit toggle smart swap, and then it'll read that barcode and then figure out what piece we attached. If we didn't have a barcode or you're not sure, then over here we can go ahead and click the exact geometry we're using. But since we already used toggled smart swap, we're good to go. So we're using the 40mm one. That's good. And then now we can go ahead and do the rotational mapping for the calibration. So we'll click go to geometry. So now we can go ahead and run the calibrations. So you'd want to make sure you first run the inertia calibration, and then we can run the friction calibration, and just making sure those numbers are close to the previous values. And then if you're running a temperature ramp or temperature sweep, then you can go ahead and run the gap temperature calibration as well. And then lastly, you want to then do the rotational mapping calibration. And once you've done all of those calibrations, then we can go ahead and set up the experiment. So over here we can then toggle to experiments. And then here you can just name your experiment. So we're going to go ahead and do test. I'm going to dump this in Rand's folder. And then under file name, these three little dots, if you click that, then you can go ahead and put what folder we want to put them in. And then the data will save as like a file within this program, so you can reopen it later. Okay, so once we have that ready, we can go ahead and go to geometry. So we want to make sure diameter and loading gap, those are going to stay the same. Gap is going to dictate how much sample you need. So right now it's at 1,000 micrometers, and so it's going to take 1.2. If we change this to, let's say, 500, it's going to be a smaller volume. So this is going to just be dependent on, if you have less sample, you might want that gap to be smaller. And then whatever the gap is, you just want to make sure that your trim gap offset is roughly 15 to 20% of whatever the gap volume is. So once you have all of that set up, we can go ahead and go to gap on this right hand side, and you're going to want to find the one that says 0 gap, and then if we click on that, it'll go ahead and lower the geometry, and then that will just bring it to essentially 0, which is pretty much touching, just so it knows how high the plate is. Okay, and then once that's good, we're going to go ahead and click yes, and we'll get to the loading gap so we can load our sample. Alright, so now we're going to go ahead and load our sample. We're going to use silicone oil for this. So we just want to get it right to the middle of the stage and just start loading it on. Alright, so now that we've loaded our sample, we're going to go ahead, so either on the computer or on the instrument, you can go ahead and get it to trim gap. So it's this button right here. And that'll essentially lower it, and it'll kind of just squish it. And if there's any left over on the sides, which there definitely is, we can go ahead and wipe that up. First we're going to go ahead and lock it, just so we don't mess with any of the pieces. And now we're going to try to clean up any of the excess goop that has fallen off the sides. Now that it looks good, we're going to switch over to the computer, and then it'll switch then to the actual gap for the experiment, and then we can go ahead and run that. Alright, so now we're going over here. We're going to go to geometry gap, so we'll click on that. and that'll actually raise it to the gap that we need for the experiment. And then we'll go to procedure, and then we'll make sure we have our procedure sweat set up. So here we've got flow, or whatever other thing you want to run. Sweep can also be adjusted and toggled to whatever conditions you need. For temperature, so if you want to just run it at room temp, you can set it at, you can just unclick wait for temperature. If you do want it at a specific temperature, be sure to adjust this and click wait for temp. And then you just set up the instrument for whatever parameters you'd like. And once you're all done with that, we can go ahead and click start. Alright, so once you've finished taking your data, so a few different analysis things you can do. So for each data point, you can right click on it, and then if we go to analyze, we can do things like best fit, viscosity versus rate, or a whole bunch of other things. And then if we do that, it'll run the analysis for you and then give you some data points. So this one was pretty good, close match to what silicon oil is supposed to be, which is what we ran. Also, if you go to the analysis tab, you can also, do the analysis that way. And once you're happy with all of your data, a couple ways to export your data. So for whatever experiment you ran over here on the results tab, if you right click it, and then you can do export, and then from there you can export this as plain text, Excel, or whatever else you'd like. I think this instrument automatically saves the data as a file, like a program file, so you can still open it up and come back to it like tomorrow or something. Additionally, if you go to File Save As, you can also save it as PDF or whatever else you'd like. So those are a couple different ways to save your data. And then once you're all done with the program, we're going to go ahead and exit out, and then we'll show you how to take down everything and clean up. So to take this all apart, first we're going to go ahead and click this lock button just so we don't mess up with the geometry in any way. Then we're going to go ahead and click the up to raise it, and that'll just raise it so that we can start to take off the geometry and all that other good stuff. So now we're going to just kind of hold this piece and then unscrew from the top just until it lets go. Okay, and then careful, it might be really drippy. So we're going to go ahead and clean that off as well. To clean it off, just don't use any super harsh solvent. So if water will remove it, you can use water. Otherwise, methanol or ethanol to wipe off all the pieces. If you do use water, just make sure you fully dry it so none of the pieces get too rusty. And then to remove this guy, we're going to, this part right here, we're going to unlock it. We'll remove this piece. And then we'll also remove these as well. And again, just go through and just, wipe anything off with methanol if you saw any spills. We'll pull this guy straight out. And then careful, if you use these cooling lines, then when you remove them, they might be gooey. So just be aware that they might release goop. Oh, let me get this out. Okay. And then lastly, to pull this off, we're going to click on this button, and that'll release the magnet so that we can pull this guy straight off. Okay, so once you're all done, we're going to power down the instrument. So just click and hold the power down button, and then eventually it'll all turn off. And then you're all done.